Howdy folks. Happy Wednesday. How is everybody doing today? Alrighty, sorry, getting a little bit of a late start here. Apparently my phone is like half dead now and doesn't know how to do alarms, which is obnoxious. Might have to get like an actual real alarm clock or something, so. Hey, good morning, David. Good to see you today. Alright, let's see. So I think all my technology is dying. It's so sad. But I am planning a trip out to Micro Center to get a PC, so that's pretty exciting. And I think swapping out to that will be really fun. So I don't know if I can do it this week, but probably next week I'll go out to Micro Center. And I can ditch the laptop here, so that should be pretty fun. Alright, so we're going to pick back up with our arrays and array lists today. So let me fire up IntelliJ here. So we got through some basic arrays on Monday. So we're going to look at array lists here and try and wrap that up. And then see how things are going. And then don't forget, we do have study group today after class from 12 to 1. So hopefully you can make that. We got to talk about Project 3 as well today. Our classes and testing. Okay, so we'll do Project 3 first, our classes and testing, and then we'll look at our array lists. Does that sound like a good plan? Let me get this fired up here. All right, let me open up this one. And this was our electric vehicle class we're going to make here, and tests. All right, come on, IntelliJ. All right, we'll start up a new project. So I was having trouble with the Java project last night. I don't know what happened here. So the Maven project worked much better for me. Not really sure. It's kind of weird. It just like nothing was running on my regular project, and it was really sad. So I'm going to try the Maven one again, and it should be fine here. We'll go next, and we want this one to be for our Monday, Wednesday. This will be Project 3. Now the problem with this one is you have to go and add your own package, which is sad, but that's okay. So just one extra step. I still think it's better than NetBeans. And it does some pretty cool stuff too. It's got some nice little helpers. It's fine. Stop asking. Yes, it's fine. All right, it's almost there, and then we can add our package, and then we can add our classes. And especially if we're doing unit tests, using the Maven package is just a little easier as well. It gives us automatically this test folder, and it will drop things in the correct location. So in the Java folder here, it's a little organizer container, we're going to drop in a new package. We'll call this Project 3. And inside of that, then, now we can actually write some Java code. So I'm going to put in my electric vehicle class. And now we've got electric vehicle. And now we can start looking at all of our attributes. So we need all these attributes here. So sure, I'll just we'll drop those in with like a comment for now. So we need a private string for make. Need a private string for model. Need a private string for color. Right, and then we needed a double, so private double for max kilowatt hours in the battery. Oh, there we go. Kilowatt. Does it not like kilowatt? Why does it not like kilowatt? Am I misspelling that, really? What does it suggest? Rename to... There's 2 T's in kilowatt. Who knew? Okay. I've been spelling it wrong this whole time. Go figure. Right, a private double, a string. Private double for current kilowatt hours in the battery with 2 T's for watts. Go figure. And a private double for kilometers per kilowatt hour. Okay, so we got our attributes. Right? Doing okay so far? We got attributes. We need get methods for all the attributes. And the only one that's changeable here is color. We're going to add a set method for color because you can paint your car, right? Once it is a Tesla Model 3, you can't change that. Or a Chevy Bolt, you can't change that. Or a Ford Mustang Mach-E, you can't change that, right? Or a Nissan Leaf, you can't change that. I'm trying to think of some of the other all-electric cars that are coming to the top of my head. There's a bunch now, right? The Rivian, they have their truck. Ford has their Lightning F-150. Who else has? I think everyone wants to do electric cars now. So we're moving there. Anyway, so we need get methods for everything. So I could type them all out, but it's easier if you let the tool do it for you. So we're going to go to generate, and we want getters here, and I want gets for everything. I want to be able to get all of these values back out. So get methods for everything, and then we need a set method for color. I'm going to generate a set for color, and only color. Right? Then, if there is no set method, the only way you can give it a value has to be in the constructor. So I'm going to add a constructor here. We'll generate a constructor. And I want you to give me everything here. Actually, we could probably assume current kilowatt hours is 0 if we wanted to. Might be easier to say we'll give it a value. Let's see, did we specify? I'm trying to remember if we did. Don't think I did. Yep. Okay, so you could take it if you wanted to, or you don't have to take it. So we'll take it. We'll make life easy for us. I think it's a little long here, so I'm going to drop that down another line. Oh goodness, that's really long there. All right. I just don't want it to run off the side of the screen. Oh, here, if I shrink this, there we go. Now we can see it again. Right, so if you pass it a string for make, we set the make to the make. You pass it a string for model, we set the model to model. String for color. There's not a whole lot of validating that has to happen here. We could do some if we wanted to. Maybe making sure these are positive, or I don't know. Otherwise, once they get defaulted, though, we can never change them again. So if you give me a bad value and I set it to 0, it's not really any good to say you have 0 max kilowatt hours in your battery. Like, what good's an electric vehicle with no battery? So might make sense, but it's nothing we were required to do here. So we got a constructor, so we can pass those values. Then we're going to add a method for charge and a method for drive. So our method for charge then was going to return a Boolean value based on whether or not the charge was successful. So if we went over the max or was negative, we'll return that false value. Right? Kilowatt hours to charge? Oh my goodness. Kilowatt hours to charge. I'm on a roll for spelling things. So we want a double for kilowatt hours to charge here. So with charge, we're going to add that to our current kilowatt hours after ensuring that it's positive. I guess we should have done that first. And our kilowatt hours doesn't go above the max. Okay, so we can say, hey, if the kilowatt hours to charge is negative, we're just going to return false right away. That was no good. Right, you can't charge a negative amount. That's not charging. Otherwise, then we'll take our current kilowatt hours and we'll add to it the kilowatt hours charge. Then we need to say, hey, if our current kilowatt hours in battery went over the max, then we need to stop at the max. And we're going to return false and say, hey, you tried to charge too much. Otherwise, we can return true. Right, so two different ways you can get false. One is negative, and one is you charge over the max. Otherwise, you get a true, right, for charge. And then for drive, same idea here. Negative, false. If we stopped at 0, false. So we'll add a method for drive. Public Boolean drive, given a kilometers to drive. Okay, so right off the bat, we can check, hey, if that's negative, is less than 0, we'll return false. Right, that's no good. Can't have negatives. Otherwise then, well, we need to see how many kilowatt hours is that. Right, so our, we need a double for kilowatt hours required is my kilometers to drive divided by my kilometers per kilowatt hour. Right, if you want to drive 100 kilometers and you can get 10 kilometers per kilowatt hour, it means you need 10 kilowatt hours. We'll take our current kilowatt hours and we'll subtract from it the kilowatt hours required. And then we can check, hey, if my current went less than 0, we're going to set the current to 0 because you can't actually get negative, and we'll return false and say, nope, that didn't work. You ran out of batteries, you can't drive that far. Otherwise, we'll return true. So again, 2 options for false here, 1 option for true. Okay, so when we talk about unit tests, for 100% code coverage, I need a test that will make this return false because I need this line of code to run. I need a test that will make this happen, and I need a test that will make this happen. Same above, a test that will make this line run, a test that will make these lines run, and a test that will make these lines run, this line run. So I need 3 different tests for drive and 3 different tests for charge to get that 100% code coverage. Right? And then the gets are kind of silly. We can do all those on our own here, and then set is not all that interesting either. And you know, I might just say set color, given the color here. It's not required. You can test the set color separately, but our constructor could call it too, right, and set the color. And I think that's probably fine. So that way we can call the constructor once, and we can test all of the gets all at once. Did we get the right values back out? Okay. So then for testing, I'm going to right-click my class. I'm going to say go to test. Now with IntelliJ and Maven, when we make new tests, we can do JUnit 5. If you're in NetBeans with Java with Ant, you need JUnit 4. Not too big of a deal. They do, for what we're doing, they do essentially the same thing here. And then we said, what do we want to test? Well, I want to test charge, I want to test drive, and then I'll add our own constructor test in a minute. This way it gives me at least, here's an empty test. Okay? And then with Maven here, what I want to do, I want to add the Maven dependency. Is probably the easiest route here. You can also do this add JUnit 5 to the class path, but the Maven dependency is probably a little nicer here. It says, hey, what do you want to add? We want to add this assertions dependency here. The fun thing that happens with that is this POM file gets updated and says, hey, there's a dependency on JUnit Jupyter. We'll add the dependency for the testing that we want to do here. This is sort of when you build your Java project with Maven, this stuff gets looked at and it does the right thing. It's kind of fun. But that should make that go away. Okay, so let's do our constructor first. I'm going to copy all of that, and we're going to have a test for the constructor. So we're going to arrange, then we're going to act, and then we're going to assert. Right, so for arranging, we need to set up all of the expected values. We're going to have an expected make. And again, I don't really want to type it all out here, so I'm just going to put make here. We're going to have a string for the expected model. I'm just going to say, again, is model. I don't really care about typing anyone out. You can pick anything you want. It doesn't matter. The string for the expected color. We'll just say is color. Right, they're just strings, so it doesn't matter much. Expected. There we go. And then a double for, now we needed the max kilowatt hours in battery. So expected max kilowatt hours in battery. We'll say, I don't know, 100, and then a double for expected current kilowatt hours in battery kilowatt hours in battery. We'll say it's 50, maybe we're half charged, and then a expected kilometers per kilowatt hour. We'll say is 10. Just make my math easy here. And it says 100% code coverage. If you got drive and charge, I'll be fine with it. Hector, my friend, thank you so much for coming on by and dropping those bits and donating to the Student Scholarship Fund over at the University of Michigan Dearborn College of Engineering and Computer Science. I'm getting better at saying that, my friend. Thank you so much for your generosity. Yeah, so SP Java, if you just did the charge and test, I'll be fine with it. 100% code coverage means everything, but the constructor test is it's not that interesting. There's not really any logic in here we're testing. We're just making sure we can pass things in the right order and we assign things the right way. So that's all. Okay, so those are the things we expect to have. And then we act. This is the code we're going to test. So I want an electric vehicle called an electric vehicle. Electric vehicle equals a new electric vehicle. And we need to give it all these arguments. So we're going to give it the make, the expected make. We're going to give it the expected model. We'll give it the color. And then we'll give it the max kilowatt hours. We'll give it the current kilowatt hours. And we'll give it the kilometers per kilowatt hour. Right, if I give it all those values, then the constructor is going to run and set color, right? Oh, okay. Yeah, that's no problem. I mean, so if you have sets for the other ones, it'll work. Now, we were only supposed to have the set for color, but, if you made it work and you added some other things, then it's probably fine. I'm not going to be too concerned. Red. Yeah, so so did you just have to add set methods for the rest of these then? Because otherwise, I guess you need a method for kilowatt max, and you need a method for kilometers per kilowatt hour. But charge and drive essentially change the current kilowatt hours in battery. Okay, so we make the vehicle, and now I'm going to have a bunch of these expected makes them all. Okay, we'll have to take a look at it later then, Red. You want to chat after class or something? So I'm going to have the actuals here. The actual model, the actual color, the actual max, the actual current kilowatt hours, and the actual kilometers. And then to get their values back out, we need to go ask our electric vehicle. Yeah, I'll commit this to GitHub. Yep, as soon as we're done. So what the actual values are, we say, hey, electric vehicle, please tell me what your make is. And electric vehicle, hey, tell me what your model is. And electric vehicle, tell me what your color is. Right, we're going to ask the class here to give us these values back. Electric vehicle, get max kilowatt hours, electric vehicle dot get current kilowatt hours, and electric vehicle get kilometers per kilowatt hour. Okay. Again, I'm not typing most of these things. I'm getting a couple letters and then tabbing and auto-completing, right? Like, don't do more typing than you need to here. Let the tool do the work for you here. Okay, so we're going to act. This is the code we're testing, and then we're going to get the values back out. Okay, so this is our test the code, or call the code we're testing, right? And get values, right? And then we can assert, right? So we're going to say, hey, these things should be equal. We're going to assert equals the expected make, and the actual make. Right, and we're going to assert equals 3 times for the make, the model, and the color. Well, the expected model matches the actual model. We'll have the actual color matches the expected color. Now, when we're doing doubles, remember there's one extra step for these asserts. You need to give it the delta, because Java's bad at math. So you say, how close is close enough here? So when I just put this in here, it's going to yell at me. It's going to say, it should yell at me in a second. It should recognize these are doubled. I guess it's not going to. That's okay. So we need to give it I think when we run, there it goes. When we run it, it would give us that error. No, that's fine. So we just say, hey, as long as they're like within a millionth of each other or something, that delta is close enough here. We'll do that for our expected current kilowatt hours and the actual current kilowatt hours, and then the actual kilometers per kilowatt hour, the actual kilometers per kilowatt hour. All right, so now we should be able to run our test. So if I make one of these using the constructor, do I get the values back out that I expected, which is just the values I handed it? Let's see what we get. It should pass here. We'll see how well it goes. Let's think about it. Yeah, I think we should have had one of those tests already from last week too. Let me double check. Thought we had one of those for reference. Let's see, where do we do our testing? Yeah, classes and unit testing. Take a look at our tests here for item. Yeah, we tested the constructor for item. So you got that one out there for reference too. But yeah, definitely all the examples, because I know we didn't have testing in the book, unfortunately. Right, and our constructor test passed. Awesome. So now charge here, right? Most of these things don't matter to charge. Some of them do matter here, right? Because if we charge a negative value, we'll get false. If we charge over the max, we'll get false. And if we just do a regular charge, it just works. So let's say this is charge successful here. And we're going to arrange, we're going to act, we're going to assert. So now we're not testing the constructor here. So I can make a new vehicle, right? So what we do want to test though is when we're a successful charge, what's our expected kilowatt hours? So we'll have a double for expected current kilowatt hours in the battery. So we'll say, hey, let's expect to have 100 here, and then we'll make an electric vehicle. Yeah, definitely, I'll commit it to GitHub. Electric vehicle equals a new electric vehicle. And now we don't care about the make, so I'm just going to leave an empty string. We don't care about the model, we don't care about the color. We do care about, though, the max kilowatt hours in the battery. So if the max kilowatt hours in the battery is 100, maybe we even want that as a double for max kilowatt hours, or as in battery. We can just pass that as an argument. Maybe that works out nicer here in the battery. And then the current kilowatt hours, we should say, is 0. And the kilometers per kilowatt hour we don't care about at this point here. We can just give it a 0. So that's my vehicle. Then I want to test some code. So I'm going to have a Boolean for the result is my electric vehicle dot charge, and we're going to charge the expected kilowatt hours. So if I start at 0 and I charge 100, it should be successful. Then I'll get a double for the actual. Yeah, let me just go copy from up here too. Actual current kilowatt hours. We'll grab that line. Let's go ask the vehicle how much it thinks right now, and then we'll assert that those match. So for the Boolean result, you can just say this assert true. You don't need to do an equals and have another variable that's true and say true equals true. We're going to say, hey, is this true? And then we can assert equals the actual and the expected current kilowatt hour. So I can copy that line. Okay. So charging should be successful. If we have 0, we should be able to charge 100 and get to the max. Right? So let's give that one a run. Let's see if that one works for us. So notice I changed the name of it too, because I'm indicating this one is the successful charge. We're going to have 2 failed charges, essentially. We'll see what we get. All right, that one passes. Awesome. So I'm going to copy the whole thing here. And then we're going to rename it here. So we'll say this one, charge returns false on negative value. Okay, so we don't really care about the max here. That's fine. We can leave it. Doesn't really matter. The expected kilowatt hour. So let's set this to 50 here. And we'll pass that in to say, hey, let's start with 50 here. Then if we charge a negative 10, we should get back at false. We can assert false. And our current and the actual should still be 50. Right? Nothing should change if I say, hey, charge negative 10. It should just right away return false and not change the value here. So I didn't want to start at 0, because just in case, I want to make sure like it didn't actually change here was all. That was kind of the idea. It probably wouldn't change either from 50, so I guess it doesn't matter too much. It's just a preference. All right, awesome, that one passed, and then we're going to have a returns false on charging over max. Okay, so if we start at 50 and our max is 100 here, then actually we want to have an expected value of 100, but if we start at 50 and then we charge it the max amount, we should get back a false, and it should stop at 100, right? So if I started with 50 and then I charged another 100, it should stop and tell me, no, you put too much in, right? This one, I mean, electric vehicles generally know how to stop charging. That's not really an issue, but like for an actual vehicle, you can just keep pumping gas in and it will spill out, right? Which is no good. All right, so now we're feeling pretty good that our charge function seems to be working. Our charge method. We've got 3 different tests to get that 100% code coverage here. All right, so we need to test drive. So again, we needed 3 different drives. So if a drive for successful, we'll have, and then 2 different failures. So we're going to arrange, we're going to act, we're going to assert. Okay, so what's going to change is our current kilowatt hours. So I think this one, let me actually grab the successful one, probably. Okay, so if we, now this one matters here. So now we need a double for kilometers per kilowatt hour. We'll say is 10 because that makes our math easy here. Right, and then if we have, say, we'll just say we're max. We have max here, and what do we expect to have? So if we drive, let's say 90. So to use 1 kilowatt hour, we need to drive 10 kilometers. So then if we drive 100 kilometers, we should use 10 kilowatt hours, and our battery should be down to 90. So if it starts at max here for the current amount, and we get to 10 per kilowatt hour, we should get back true, this was successful, and we have 90 left in the battery. So let's give that one a shot. And then while that's running, I'm going to go copy our failure here. Here, we'll just copy this one, I guess. This will be returns false on negative value. Right, so we should still be at the 100 here. Here, if we try and drive a negative amount. So it shouldn't change anything, and then this should be a false result. Okay, and then if we try and drive more than the max here, so if we start off with, say, our current kilowatt hours was like 1, and we try and drive 100, we should get a false result, and we should end up with 0, right? So if we have, I mean, we can even do it, that's fine, we'll do it larger. So we'll do like 10,000 here, and we'll start off at max here. Right, we should be able to go 1,000 kilometers with our math here, so if we try and go 100,000 kilometers, this will, even 10,000, this will definitely fail, right? We should get back a false result, and we should have no battery left, no charge left in the battery. So this returns false on going below 0 charge. How about that? Okay. And then I think we can run our tests. So let's run all of them now. Let's run all the tests. And we should see 7 tests pass. 1 for the constructor, and all the gets essentially, and the one set, the set color. And then 3 for charge, and then 3 more for drive. To get that 100% code coverage. That was the goal. Okay. Looking good so far. So let me fire up GitHub here. And we'll go from there. Questions, thoughts, or concerns? Classes and testing? All right, so we need to actually wait until we get to files to do the next project, because our next project is based on files here. So if we go take a look at our syllabus and our schedule, we're a little bit behind here, but I think we'll be okay. is it shouldn't be too big of a deal here. Let's see what we got here. Yeah, so if we can finish up arrays today, so we'll start the files project. It's going to be not as big as I had planned, given you're going to have to get pushed back. So, but that way we can still start the final project and have a whole 4 weeks to do it here. So 1, 2, 3, and 4 weeks. So I'll make project 4 a little smaller here. We'll have a lab on ArrayLists we'll work on after this, and we can go from there, okay? So I appreciate you folks being flexible. This is project 3. Whew. I need some more coffee. Come on. Wake it up. Wake it up. There it goes, project 3. Commit and push. There we go. All right, so that should be out there on the website. Let's see, it'll, oh no. Internal server error. Uh-oh, that sounds like GitHub's having issues. Let's try one more time. If it's not going, we can take a look. Maybe GitHub's having some issues. This happened last week. I think they were having some trouble, but okay. It worked that time, so it's good to know. All right, I'll leave that open for next time then. And we're good to go here. How about we take a quick break now instead of breaking in the middle of ArrayLists? Is that okay with you folks? Take a quick one and then we'll come back in 10 minutes. We'll go get some more coffee. All right, let me put some music on. We'll take 10. And I'll be back in just a second. There we go. That puts us at 10:56 or so. All right, I'll be back in just a minute. Coffee time for sure. That's right. Howdy friends, welcome on back. Alright. So here we tone that down. Alright, so let's go open up our other project here. Did we have... There it is, yep, that's what I wanted. Our Arrays and ArrayLists project. Excuse me, so we'll get... just trying to keep it all in one place here. So we did our loops here for scores, right, where we knew how many scores we had. Now, one of the things here with arrays, which is kind of frustrating, is that once they're sized, they're stuck. So once I say I have 5 values, I can't make it any different. Or what if I don't know how many values I have to start with, right? So let's put all of this in a different method here, if you don't mind. We'll cut all that out and put this in with arrays. I'll put all that in here. So we have it later, but then we won't clutter up our main, okay? So we can reference it all after. So for this one here, we'll say, hey, this is the regular project, right? And it worked. Let me just make sure it runs. I was having so much trouble with just regular projects. I wasn't getting this out directory. I didn't know why. IntelliJ was just taunting me. Didn't work on Tuesday. Yeah, it was fine. Okay. That's the weirdest thing. It's the weirdest thing. Huh. Alright, anyway, sorry. So with ArrayLists, what we get is flexibility. We can add items to it to expand it, and we can take items out to shrink it, which is super cool. So we could build an ArrayList and just say, hey, tell me what items you want to add to your shopping list. So we'll tell them, we'll say, I need the scanner for keyboard. That's all right, we'll add one of those. Scanner, we'll call it keyboard, equals a new scanner, given system.in. Yep, and import the class here, thank you. And then we'll say, hey, enter an item for your shopping list, or done to... I guess done is probably pretty clear here. And then we can have a string for item is keyboard.next line. We can say while my item dot equals ignoring case done, and while not that, right? As long as it's not done, we'll take and keep on going here, but we need a place to put it. So to make an array list, now array lists are a little funny here. You need a particular syntax. We used to use these greater than less than signs, these angled brackets, to say, hey, this is going to be a type of string. I'm going to store strings in my array list here. We'll call this items. We say equal the new array list, and then open close brackets, and then parentheses. So the type of string here, so you can put strings in. So similar when we did arrays, right? It would just be string, items array equals a new string array of size something here, right? It would be a similar approach. And I don't know if we mentioned it with arrays, you can actually put the braces on either the variable name or the type. Either one is perfectly fine. So string array called items or string items array. I don't remember which people prefer. But similar syntax, right? But now you don't have to tell it a size. So there's no size required. What we get to do then is we say items dot add, and we can add to it the item here. So add will add the item to the end of the array. Right? So if I had 10 things, it's now the 11th thing, it's index 10. If I had 0 things, it goes to the end, it's now index 0, it's the first thing. Right? And then we just keep on asking them, enter an item from the shopping list or done, and keep on going. But we don't need to retell it it's a string, it's just an item. Okay? How's this one sound? So we can just keep adding items to the array list, which is really handy. And then when we're done, we can loop through it. Same idea here. So we can do both loops again. So we can say for index is 0, index is less than. Now, there is no length property, so items have a size method, which is a little bit funny, but that's okay. So instead of .length, we use .size with parentheses. So with an array, right, it was just .length. This was an attribute here that we had access to. It was not a method. With array lists, it's the method named size. So it's a little bit different here. What we should say, use .size instead of .length. Does that make sense, kind of putting it up there? Then we'll say index plus plus. And then to get a value back out, right, I want to say, hey, print my items dot get the index. So use get instead of the square brace notation. I want to say use get index instead of square brace index. Okay, so that's the big differences here. Now there's other things we can do with array lists. So with our array lists, right, we can say items, if you wanted to change a value, you'd set a given index. So we can say, okay, let's set index 7 to a value here. Versus with our arrays, right, we just say, hey, I want to set index 2 to this one over here. Right, so this is the set and get. With array lists, it's a separate get and a separate set. So you can get or you could set. So there's a little different here with that notation. So it takes a little bit of flipping back and forth. But what's nice about these is you can just keep adding to them as much as you want. You don't need to know what size it is. Versus an array, how would you do a shopping list? Well, we could make it size 100 and then hope no one has more than 100 things to buy. Because you've never been to Meijer with me when I go shopping with my kids. We fill like 2, sometimes 3 carts. It's always fun taking the kids. Costco's always a 2-cart trip, but that's never near 100 items because like they're just so big. But Meijer, we definitely we pile those carts up, which is a lot of fun. And then what do? We'd have a bunch of empty values too, which is no good. And I also mentioned you can take things out of your shopping list here. So let's give them like maybe a menu here. So when we're done, so this is printing them all out, or you can also do the enhanced for loop. You can say for string item in items, print the item. Oops, no, we can't call it item. Oh, I'm going to call it I, and I'm going to feel bad about myself. String I. No, string I. Thank you. Here, because we already have something called item here, so it wasn't letting me have another string called item. You can still do the read-only loop. Only loop works with array lists. Now, remember when we talked about this enhanced for loop, I think I said I called that a collection, right? The enhanced for loop. In the array, or a collection, so it works with array lists as well. Doing the same read-only enhanced for loop here, which is fun. So you can you can get the values out, but you can't change them. If you want to change the values, you need to be getting the indexes, so you can call the set method. So it's even a little cleaner too, what's happening, right? If you're not calling the set method, you're not changing the value inside the array, or the array list. Versus with the array, it's like, oh, do you really know? Because sometimes it's the get, sometimes it's the set. So I like array lists. So let's see if we can build a shopping list here. So what do we need to buy? I ran out of my already ground coffee. I've got beans that I can grind up myself, so I need to go grind some coffee, but I also like the already ground stuff too. Let's see. So we need some coffee. We need more milk. We drowned our last gallon of milk. We need more apples and bananas. And we'll say that's done for now. we should get our list back out twice, right? Once with the by index here, and then once with the enhanced for loop. Okay, so we can get the values out. Now, if I wanted to, I could go and say, do you want to remove any item? So with the array list, it's super cool. So we can have a string for remove equals the keyboard.next line. Oh, maybe we'll call this one the choice, right? Keyboard.next line, and then if choice equals ignoring case is a y, right? If it is a y, and then they'll say like y or n or something here, we can ask them what item to remove. What item do you want to remove? Oh, in quotes here. I'm reading chapter 11 in the textbook, and information you have to read chapter 9 to really understand. Which one is 11? Let me double check here. I don't actually remember all the chapters. Yeah, working with arrays. So we don't need that comparable interface. We don't tackle all of the things with arrays. We just do some of the stuff with arrays. No, just ignore that part. It's not all that important here. For working with arrays, here, chapter 11. Yep. Let's see. Oh, okay, we still have, that's right, we have one other thing to talk about arrays too. Thank you for reminding me. So if we wanted to remove something here, what item do you want to remove? We'll have the item equals the keyboard.next line. And then I can say my items dot remove, and I can say, hey, remove the item. It will go remove that first time that it finds. So you can add something to the list more than once. This will only remove the first one here. It's the first occurrence it finds. It finds. And then I think, if I remember right, removes is going to give us back a Boolean result of a true or false, whether or not it worked here. So then we can say, hey, the Boolean result, or we can even just do this. We can say, hey, if, oh my goodness. Oh, goodness. If items remove, we can say removed successfully. Or maybe we only care about it. How about if it doesn't? We can say that item wasn't in the list, right? If it didn't remove, if we got back a false result, we can say it didn't work, right? And then maybe this could be a whole other loop as well. I don't know. There's all sorts of fun things we could try. Occurrence. 2 R's? Occurrence. 2 R's. Okay. Spelling's not my strong suit. And then we'll print out the list again here. Okay, so let's see if we can add some items and then remove them. And please don't remove coffee from my shopping list. I'll be very sad if you remove coffee. Coffee is required. Let's see what we get here. All right, so let's add coffee, and we need milk and eggs, and then done. All right, what do you want to remove? Yeah, let's remove something. How about we remove eggs? And we get now just coffee and milk. So it will size itself and fix itself up to fit just what's left, which is super cool. So I've got indexes 0 and 1 here. Before I had 0, 1, and 2. So array lists are much more flexible than arrays. So I'm almost always going to be a fan of array lists, unless you know exactly how many items it's going to be, and you never need to get bigger and smaller. Then an array is perfectly fine. So like if we were doing like if we wanted to make a little tool or a little program that let us play Powerball, we'll play the Powerball lottery, right? Excuse me. You know, there's only ever 5 white numbers that are picked on the ticket. That's never going to change. So an array should be fine. You don't need the array list function or features to say, hey, let me go add a bunch of values. Now, arrays also do other cool things with array lists. Right? If I take my items, I can say, hey, does it contain something here? And I can get back a true or false real quick. I can just ask the array list, hey, is coffee in my list? And it will go tell me. I don't have to loop through the list myself and say, hey, is coffee one of these values? No, it's not hard to do it yourself. You could do one of these loops here and say, hey, if the I equals coffee, then it's in the list. We'll return true. If not, return false. we could build it out ourselves, but it's nice that it's already built in. Okay? All right, and the last thing we wanted to do here was look at two-dimensional arrays. So an array of arrays, or an array list of array lists. And this is where it gets a little crazy here, but just follow with me. I think we can do it. I think it'll be okay. So that was all of our shopping list here. So let me grab all of this here, and we'll cut that out. And we'll say that is the array list, static void array list. Put all that in here, just so it's not getting clobbered up or cluttered up here. So what we could do is we can make an array of arrays. So if I want, I can have this character array. We'll call this our board, equals a new character array of size 3, size 3. So the first, what is being stored in this array is another array of characters. It gets a little funny here, but I can say, hey, character array, this is row 1 equals my board at index 0. Right? Because the first row is another array, or the first item is another array. Red, you can find the position. So I think that with that one, it is index of items dot. You want to say index of, and it will tell you the index that it's in. That's a good question. Yeah, so I don't think you can get both at once. You can either get the index of it, or you can tell whether or not it's in it with contains. Because contains is just a Boolean result, so it's telling you, hey, it's just going to return a Boolean here. But if you want the index value, right, it'll get. And this is it's important to notice you'll only get the first one, so you can also use a last index of to get the last one. Get a couple fun things there. Okay, so an array of arrays, right? You can imagine is like if we wanted to kind of draw it out here. Now, usually we do this as rows and columns because it hurts our head less. And I think that is easier to kind of conceptualize here. Sorry, if I'm touching my screen, it makes my camera all wobbly. But essentially that array then is an array of, and then we could have like characters, I don't know, A, B, C. That would be the first item. So this is index 0 here. Then we would have another array of like D, E, and F. That's an E there. I'm terrible at writing. I apologize. E and F. That would be index 1, right, in a two-dimensional array. Now, this gets a little awkward because then this has its own indexes 0, 1, and 2, and 0, 1, and 2. So referencing these gets a little funny. So what we usually do is we draw this as a two-dimensional array. So we'd say, hey, imagine this is row 1 here as A, B, and C. And imagine this is row 2 here as D, E, and F. Right? So this is row, and these are columns here. And then it's a little easier to kind of picture in your head, okay, here's the row and here's a column here. Because to access any of those or to get any of those values, right, we would say, hey, I want the board at row 1, column 1 equals something. Right? I could put an X in there or something. Right? Get a row and a column out. So it's row and then column, sort of. Right? So it's row index, column index. It's generally how we try and conceptualize this. So I think that makes it a little easier in your head. Now, this first way is still fine, right? You can say, okay, the first item, and this is your first index then, and then this is the second index here. Yeah, matrix. Yeah, it's a matrix. QAQ. I don't know what QAQ means. Apologies. I never actually took linear algebra. It's on the list of things that I'd like to do. And I was going to take it, but I got a little busy here. So I think if things ever slow down, I'll go take a linear algebra class. I've got a book on it, but let's be honest, if I'm not like sitting my butt down in a seat taking the class, I'm not going to be all that motivated to read the book. I'm not really as good as some other folks at that sort of self-motivation. Ooh, there's a really good story about this guy. This is totally worth it. Totally worth it, I promise. American Practical Navigator. Bowditch. There we go. Nathaniel Bowditch. Nathaniel Bowditch. This guy is a legend. Nathaniel Bowditch is amazing. So he taught himself calculus while working in, was it Boston, I want to say? Yeah, he taught himself Latin and French so that he could read Newton's Principles of Mathematica. He found errors in the New Practical Navigator at age 18. He wrote to them at the Royal Society of London about all these errors. Let's see, that was a captain. Where is it? Yeah, bookkeeping apprentice at 12. At 14, he was studying algebra and then taught himself calculus. Like, this guy here, you know, let's be honest though, in the 1700s, there probably wasn't a lot to do. So maybe that was a little easier to self-teach yourself, but this guy was a literal genius here. And he kind of revolutionized navigation on the seas. But there's a term for that, and I have no idea what it is. Navigating the seas. I forget what the term is, but I read a biography on him. Actually, one of my kids did for school, and I was like reading along with them. It was like a read to them sort of thing we do for our homeschool stuff. It was amazing. So this guy is super cool. So he's good at teaching himself. Me, not so much. No. Pro, are you crying about two-dimensional arrays or matrix algebra, linear algebra? All right, so anyway, you can get at things by row and by index. So we don't actually want to access anything here. Oh, QAQ is a crying emote. Oh, is that like tears and eyes and tears and a nose or something? Okay, Gilbert Strang's linear algebra course. There we go. There was a one on algebra online course. Was it Coursera or something? Udemy. I think this was supposed to be a pretty good one. We want Gilbert Strang. Oh, is it this one here from MIT? Nice. Okay, I will keep this in my list of things to do here. As taught in spring 2010. I guess linear algebra hasn't changed much. Go figure. So we can watch his video lectures? Can we really do that? Oh, that's so cool. Look at all that chalkboard. Look at all that chalkboard. There's a lot of different crying emotes. It's any way you wanna write them out here. 34 lectures in a 15-week course. So they're meeting more than twice a week. Is that what's happening here? Are they meeting 3 times a week? I feel like that's probably best for you though, right? Like if you can just do like an hour and a half 3 times a week or something, rather than sit there for 4 hours straight. You know, after 2 hours, you're not remembering anything anyway, right? Like, you know, it's not going to happen. So I think breaking it up is probably best for the learning process. Difficult on the commute though, if you have to commute to campus. Oh, okay. So that's a common emote if you're Chinese. That's good to know. That's really cool. Like everyone can kind of develop their own set of emotes or yeah, school schedules are rough for sure. I'd like to imagine that online asynchronous learning is good because if we've packaged it well, you can do it at your own pace. The problem is you do it at your own pace. And my own pace in my experience when I take those classes is, oh, I'll fit it in later. Oh, I'll fit it in later. I'm busy today. I'll fit it in later. And then later never happens. And then I fail my class and I have to drop it, which is kind of depressing. And, you know, life happens. So I think the sitting there in person on a schedule, because this is the only time I can do it, helps you dedicate that time to it. I don't necessarily know if there's other advantage. I mean, the other advantage of in-person learning is you can be like, hey, I don't get it, I'm lost, right? And like ask that question right away. So I think that works out a little better. Did I tell you folks about the Summer Momentum Scholarship yet? I'm forgetting which class I told what. But don't forget, that's open until April 22nd. So if you have some credits already, here, Summer Momentum, there we go. Okay, I did. Okay, cool. So don't forget to apply. Like if you've got 18 or more credits, they'll literally pay you to take a class. That's like one class for free, 3 credits for free. So we definitely want to give that one a shout out for summer classes here, if that's your thing. If you want to take the summer off, then take the summer off. I totally respect that, because once you get into the real world, you don't get summers off unless you are a teacher. Like there's no other industry that does this sort of just take the summers off thing. So yeah, sure, I'll post it. Why not? I'll do that. I gotcha, SB Java. I'll do that. What? How did I get there? Okay, why not? Summer scholarship. You get to apply for, you are taking summer classes and have completed more than 18 credits. And of course we got to change the font here to something more respectable, like Comic Sans. All right, awesome. All right, so anyway, 2-dimensional arrays. So what we want to do here, we want to see if we can't kind of work this out to be a tic-tac-toe board. Okay, so we're going to have a character here for the current player. We'll say is X. So X will go first here, right? And then we need a way to print the board here. So I want to, because I'm going to print it more than once here, I'm going to make this a method. Static void print board. And remember, you can pass arrays to methods. So I can make a method here that prints it. So I'm going to say for, now this is a character array. I'm going to call row in the board. Right, so the first loop here will get each row, right? And then what I want to do, I'm going to print, I could loop again, but this is kind of quick. I'm going to say row of 0 plus a pipe character plus row of 1 plus the pipe character, because this is not too tricky here, plus row of 2, right? Row index 0, row index 1, row index 2, print that here for each row. But I want to separate these things too, so really I don't even want to loop this here. I'm going to feel a little bit bad here, but it's okay. Let's do this. So instead of row, now I need board. So it's board row 0, board row 0, board row 0, and then I want to print a bunch of dashes here. And then I want to print the next row, which is row 1, column 0, row 1, column 1, row 1, column 2, and then I want to print a bunch of dashes. And I want to print it again. 2, 2, and 2, row 2, row 2, row 2. Okay, so that'll print the board. So we'll print the board. And now, really, we need to give it the board here. Sorry. I want to keep doing this until the game's over. So I'm going to say while not game over here. Let's keep on doing this thing where we print the board, and then we ask them where do they want to go. So then we'll say pick a column, enter your row number, and then we'll get an int for the row index is going to be integer.parseInt. Given the keyboard.next line. Oh, we don't have a keyboard yet, sorry. So we need scanner keyboard equals a new scanner. Given system.in. In. There we go. And then we need a column index to your column number here. That'll be our column index. Keyboard.next line. Keyboard, my goodness, friends. If you can spell, it'll save you some time here. Don't worry. Let's see. So we get row and column, and then let's say we'll try and place a value. So we'll say try place the row index, the column index, and the board. Okay. So to try and place a piece, then, so public static void try place. Given the int for the row index, the int for the column index, and the character array of the board. Now, actually, when we make this board here, I know what it is. So I can give it the array initializer syntax here. And I can say, hey, it is an array of space, space, space here for the first row. Then I give it the next row. So you can create this here as we go, because I need to have these spaces, because I know what those values are here. I'm going to build it out initially to start here. So this is my empty board of spaces, because I want to have the space characters there, right? So I'm going to try and place. I'm going to say, hey, if the... Now, I want to make sure that you give me a valid row and a valid column. So I'm going to say if row index is less than 0, or the row index is greater than 2, or the column index is less than 0, or the column index is greater than 2, or my board at row index at column index does not equal a space. If any of those are true, we're just going to return false. We'll make this a Boolean here. Actually, we don't even really care. We're just going to do nothing, I guess. All right, so let's flip it then. So we'll say we're greater than or equal to 0, and we're less than or equal to 2, and oops, the column index is greater than or equal to 0, and it is less than or equal to 2, and it is open here. So this is if these are all true here, then we can go place the piece, right? So then I can say my board at row index at column index. Oops, so we also need to tell it the current player, right? So we also need a character for current player. Current player. We'll assign it to the current player. So we're going to say, okay, if you give me a valid row and a valid column and it's open, I'll go assign it, right? I just wanted to, all that logic just kind of goes in this. We're just breaking it down, doing this functional decomposition here, right? We'll place the piece. So we should probably tell them whose turn it is, right? We'll say current player plus this turn. Okay, X's turn, right? Enter your row number, enter your column number, place the piece. If the game's not over, print the board, right? And when we're done, we're going to print the board one last time. Given the board. So how do we know if the game's over if we're playing tic-tac-toe, right? Well, let's see. So this is a public static Boolean game over. So given a character array, two-dimensional array, call the board. So a couple things that can make the game over. What's up?
Sky called. He wants to play.
What? Why is he? Alright, that's fine. You can play with him.
Yeah.
All right.
Fortnite? Can we play?
Yeah, that's fine. Play with Sky. Apparently their cousin's not in school today. That's okay. So the game over. So a couple ways. Either it's a tie game, the cat's game, or somebody won. Right? So we're going to return these game is tied, or someone won. Right? Either one of those. Right? Okay, well, how do we do those, right? We're just breaking this down. So Boolean game is tied. What? Why do we have a flash drive? Oh, that's first. Oh my goodness. All right. Game is tied, given the character array of the board. So the game is tied if there is no space. Right? So we're going to say for row index, or I'm sorry, for the character array, we'll call the row in the board. And then we're going to say for the character, this is, it's not really the column, right? It's the mark, I guess. I don't know, spot maybe in the row, we'll say. If the spot is equal to a space, I'm sorry, a space character, right? We're going to return false. The game can't be tied. If we've gone through all of this, for every row and for every spot in that row, if we haven't found a space, we're going to return true. Game must be tied, right? Because all the spaces are full. Right? Okay, so we can do game is tied. Now, somebody won is a little trickier here. So public static Boolean, someone won is given the board here, right? We need the board. Always given the board. That's right. Somebody won given a board. You can win by row, you can win by column, or you can win by diagonal. So we're going to return win by row. Log in. There you go. Yep. All right, so a win by row, given the board, or win by column, given the board. Type in the wrong spots here. Or a win by diagonal, given the board. Right? Any one of those is true means somebody won. Okay, well, let's break those down. Let's do win by row. So we're going to define, this is win by row, right? Win by row. Here, so to win by row, we'll say for row, right? For row in the board, we want to say, goodness. That'll clean it up after. If the row at 0 does not equal a space, and the row at 0 equals the row at 1, and the row at 0, index 0, equals the row at index 2. Right? If you're not a space and you match, we're going to return true. If we've gone through all these things and we haven't returned true, nobody won by row. Right? So look at every row and say, if it's not a space and they match, somebody won. We don't care what player it is. Like, the person can look at it and see who won. It's not too tricky. We don't need to say X is 1 or O is 1 or anything. Let's say they match. Okay, so it's winning by row. Great. Then let's do a win by column. Win by column here. Now, winning by column, we want to do a little bit differently here. We want to look at each column at a time. So we're going to say for int column index is 0. Column index is less than 3, right? Because 0, 1, and 2 are valid here. Column index plus. We'll say if my board at row 0, column index, does not equal a space, right? And my board at, now then needs to match the next one. So row 0 for a given column needs to match the board at row 1 for that column. Right, so column 0 will be the left line, column 1 will be the middle line, column 2 will be the other one. So we need to check all of the rows here as we go, right? And then it matches what's in row 2. So row 0 matches row 1, row 0 matches row 2. If all of that's true, we're going to return true. We have a winner. If we haven't found a winner by column, then we'll return false. There is no winner. Nobody won by column. Now, winning by a diagonal is a little bit trickier here. We're going to feel a little bit bad about this one, but that's okay. We're going to do it the hard way, because there's only a couple things that need to match here. It won't be the worst thing in the world. Now, if you notice, both diagonals go through the middle. So I'm going to check first. I'm going to say if the board at 1, 1 does not equal a space. So you have to have someone in the middle. Then I'm going to check either this diagonal or that diagonal. Right? We can check either one here. So if that one's not a space, right, then we're going to say if they all match, right? And then board at 0, 0 equals board at 1, 1. Right? And board at 2, 2 equals board at 1, 1. Right? So if the center matches and then 0, 0 matches 2, 2. Right? So if you kind of imagine this, right, this is 0, 0, this is 0, 1, and then F, G, G, H, and I, right, would be 2. So 0, 0, 1, 1, and 2, 2. Right? That's one diagonal here. So if they're not matching and those ones match, right? Or, this gets a little bit funky here, but that's okay. We'll say or then board at, now we want 0, 2 matches 1, 1, and board at 2, 0. 2, 0 matches 1, 1. return true. Else return false. Now this gets a little bit silly here because I'm just saying if this is true, return true. So I can just say return. Now that did not clean that up as nicely as I wanted here. So I wanted like these to be one thing. There we go. And these to be one thing here. There we go. That's a little nicer here. Let's put that one down on that line. That's probably fine. So we're saying, okay, the middle's not blank, and then either this diagonal matches or that diagonal matches. That's either true or false. Okay. Boop. Given the board, do we get it? Do we figure it out yet? Oh, that's right. We just need to pass it the board. That's right. Sorry, this is just the board. It already knows it's a character array, or two-dimensional character array. There we go. Do we make that happy? Given the board here. So as long as there's not a game over, we should be able to play tic-tac-toe. Give it a shot. So who wants to play against me? Shout it out in chat. I'll let you guys be X's. And tell you what, if you can beat me at tic-tac-toe, I will give you 100% on your lab. No questions asked. Now, the trick part of that is you can't beat me at tic-tac-toe. Oops, we're printing out too many dashes here, so that's a little bit ugly on our print here. So we'll trim that down just a little bit here. So I think just take out 2 dashes here, and then we'll rerun it. Oh, we never asked for... I did a keyboard next line. Why didn't it ask? Oh, game is not over. Uh-oh. We must have an error here, because it stopped. It said the game was over. Uh-oh. Game is tied. We're going to return false. Okay, so that's fine. And then somebody won here is win by row or win by column or win by diagonal. It's not empty. It's not empty. It's not empty. Return true. True. Turn true. It should have done that. That's interesting. You messed something up here. I broke it. Usually this works. Let's try that again. All right. So, let's see. Game. Well, not game over. All right. So there's a problem with game over. That's okay. We'll figure it out here. So we put a breakpoint in here, and we'll run in the debug mode. We'll see which one of these is returning true. All right, so I'm going to step into here. Here's game is tied. Right, so we're looking, if we find a spot, we're returning false. So game's not tied. Now we'll step into someone won. Step into win by row. We're going to look here. That's a false. All right, no one won by row. Okay. And then we want to step into win by column. Win by column. Nope, nothing. We return false. Good. And then how about a win by a diagonal? Win by a diagonal says we are not... Right, it's already telling me, hey, this one's false here. So we're going to return a false. So that returned a false for game over. Not false should be true. How? My goodness here. What happened? Those are both false. False or false. The whole thing is false. Not false should be true. Oh my goodness. Hang on. What did we do wrong here? Let me try one more time. How? I'm super confused because I think those were all false, weren't they? Okay, which was the one we win by diagonal? We said false and. The whole thing should have been false. Let's try it one more time. Debug it. So game is tied. If we step into false, Okay, someone 1. Did we get back what that was here? I didn't. Oh, goodness. I wanted what is this someone 1 here. So let's put a breakpoint there. It's false or false or false. The whole thing should be false. Try it one more time. Step into our code. So winning by row is false. Oh no, I missed it. Oh goodness. Winning by column was false. Winning by diagonal, they were all false. Weren't they all false? Goodness. All right. Winning by row is this one here. Boolean column. This is obnoxious. I'm sorry. Win by column. And Boolean diagonal. This one by diagonal. And then we have row or column or diagonal. All right. Put a breakpoint there. We'll see which one of those it thinks is true or false. Now I can actually see what was returned a little easier here. Oh, diagonal is true. How is win by diagonal true? I want to know how. All right, one more time. Okay, so win by diagonal. We said we are not empty, and 0 matches 1 and 1 matches 2, or this one here. So I have an or, so this is false and this or this. I've messed up my parentheses here. I'm supposed to have one more set of parentheses around this or block. That's what it was there, friends. So these need to be OR'd together first and then ANDed. Sorry about that, because if this is false, then it doesn't matter if these ones are true. So the whole thing, okay. Sorry about that. That was what it was here. All right, now we can play. All right, do you guys want to go? Pick a row and pick a column? All right, somebody in chat, pick a row, pick a column. It's X's turn. Let's go. Anybody? Come on. Who wants to play? I can play by myself. I mean, I'm still going to tie. All right, 0-0. There we go. Thank you. 0-0. All right, so I'll go 1-1. Oh, no. I forgot to change the player's turn. All right, almost there. Sorry, we'll come back to it. So after we go, right, so try place then was going to return a true or false, right? Oh, it wasn't going to. We needed to change their turn. So this needed to be a Boolean. We do need to do this here. We'll return true, otherwise we'll return false. All right, so then if try place worked here, then my current player equals, so okay, so then if current player equals an X, then we'll say current player equals now a Y, or I'm sorry, O, X's and O's here, else, so if it wasn't X, then it's going to become X. If it was X, it'll become O. All right, if the placing worked. Let's try it again. Fourth row, second column, idiot sandwich. There we go. I like it. I like it. You're just testing to make sure it works, right? Testing our can place. I like it. Because this is what users will do. So 0-0 for SB Java, 1-1 for me as O, and then 4-2 for idiot sandwich. Didn't work. It's still X's turn. All right, X, where are you going to go? Let's go, chat. Give me your best shot here. Let's see what we got. Two, one. Okay, 2-1. All right. Let's see. So I need to go. Oh, sorry, Red. I'll play. Oh, there's no 3-1. You're messing with me again. Index is 0, 1, and 2. So where should I go? I'll go. How about 1, 0 here? So I got a 2 in a row. I got a 2 in a row, folks. I'm gonna win next turn. Definitely gonna win next turn. Red 2, I'll try your 3-1 here. Oh, it's still X's turn. 3-1 was not valid. 1-3. All right, 1. You want 1-2? You mean? Right, index 2. All right, so now my O's turn here. So let's see. So I'm going to go at 0, and we'll go 2. How about that? How about that? Can we restart? Sure. Yeah. Can play another one. Why not? All right, X's turn. Chat. Let's go. I got a 2 in a row again. You gonna block me? Of course you're gonna block me at 2-0, right? I know where you're gonna go. And I'm gonna go at 2-2. I'm gonna block you. And then all we got left is 0-1. And then the game's over. Cat's game. GG's, yo. GG's. All right, so let me commit this here for fun. This was our array lists and 2D arrays. So you can do 2D array lists just the same here. Yeah, we got to do the lab here. Yep, definitely. So let's talk about the lab real quick. We're going to practice array lists here. Yep. So we're going to build a class list here. So this will be lab 11, classroom. So similarly like we did with our shopping list, just ask them to enter a class that they're going to take this summer. And we'll just keep on going until they want to stop. And then we'll print it out when we're done. So don't need to do anything too complex. Just want to practice here. And then we'll ask them, hey, review your schedule. Is there anything you want to take out? So CIS 1500, winter 2022, lab 11. Let's see. I know if I wouldn't have had that bug, it would have been a little faster. But Oakland, Community, College, Java template. All the troubleshooting is good examples. Don't worry. It happens to everybody. All right, so we'll copy that. So for lab 11, due next week at 10 a.m. This will be 10 points in labs. A text submission in the labs category. So write a program, submit feedback, pull request URL. Write a Java program that uses an array list to store a list of classes for the user for the summer. Ask them to enter classes until they are done, storing them in an array list of type string. After they are done, allow them to review the list, like print it, right? And ask if they want to remove any. Let's make this a loop. So use a loop. Allow them to remove classes from the list until they are done. Print the list one last time and tell them to have a great summer and apply for the scholarship, the Summer Momentum Scholarship. See what I did there? Look at that. All right, I thought it was clever. All right, folks. So very similar, we'll add one other loop here when we're due with our array list. We won't get to the two-dimensional stuff. You'll tackle more of that in Java 2, Object-Oriented Programming Java, but I want you to see that it exists and see that it's not too terrible, right? I think this tic-tac-toe part was kind of fun. At least I find it entertaining here. All right, so I'll commit this all to GitHub, and oh yeah, we already did that here, and we should be all set. So is there anything else you folks need? Let me know. Don't forget study group right at 12 o'clock, 12 to 1. Definitely encourage you to go. Get that extra bonus point on your quizzes here, because I'll post the quiz now on Chapter 11, and we'll go from there, okay? All right, folks, you take care, and I will see you around. Bye, everybody.